Back in December, I joined a game jam called the Simplicity Jam with a game developer named Marcin. We made a top-down 2D stealth game named Mr. Cloak that had the simple objective of finding a key in a dungeon and escaping before the enemies caught you. We'd created 3 enemies, but none of which were super fleshed out / refined for the purpose of the game jam, and things like the lights were just static 2D images that didn't interact with the world around them. We also only ended up with 3 levels during the game jam itself, which left a lot more to be desired from the gameplay. So today, I'll walk you through part 1 of our journey to take this small game jam game and turn it into a full game to release on Steam and the App Store. Let's get into it. So right off the bat, the first and most obvious things we need to implement are dynamic lights and pathfinding for the enemies. Implementing pathfinding is important because before, if a henchman started chasing Mr. Cloak, he would just take a straight route to Mr. Cloak's location, regardless if there was an obstacle in the way. Adding dynamic lighting is also important because currently, lights are just static 2D images, which is fine until you put any light against a wall or a corner and it overlaps into the outside of the level or through a wall. But let's start with tackling the pathfinding first. Alright, so like I said before, we need to implement pathfinding so enemies don't get stuck on walls and can navigate around obstacles in their way to get to where they need to go. So most games choose to implement the pathfinding algorithm A*. And luckily for us, there's plenty of free A* pathfinding libraries that I can import into my Unity project, so I don't have to spend valuable development hours trying to code it myself. But it's still fun to know how these things work, so I'm going to teach it to you. Welcome to Computer Science. I'm going to be your teacher, Professor Pete. If you never did computer science, then that is okay, because I'm about to teach you your first algorithm in just 2 minutes. But you gotta pay attention. Let's get into it. Okay, so I'm going to simplify how this algorithm works a little bit for the purpose of keeping this short in the video, but essentially, you start by making your game world into a grid of movable spaces. So we exclude all the spaces taken up by walls and other obstacles. Now, we need a starting point and an ending point. We're going to take the henchman, for example, as our starting point, and our player here as our ending point. And the henchman wants to get to our player as efficiently as possible without running into any walls or obstacles. As we can see, obviously the most efficient direction to move in for the henchman is going to be up and to the left to start, and then down towards the player. But let's see how the algorithm determines that. So the algorithm looks at all the spaces in the grid around the henchman and determines a value for each one of them of how favorable it is to move in that direction, with the lower values being the most favorable. The value of each space is determined by calculating the distance from the space to the starting point and the space to the ending point, and adding those two values together. So for example, the distance for all these spaces from the start is just 1. And the distance to all the diagonal spaces is 1.4, because a squared plus b squared equals c squared, which is the distance to these diagonal spaces. Then, we calculate the distance from these spaces to the ending point, and add these two values up to get our final values for each of these spaces. We then keep a list of all of these values, and one by one explore the spaces around the one with the lowest value, and add all the new values of the spaces around that one to our list. We'll then keep going by always choosing the one with the smallest value and keep exploring. After exploring enough, we'll finally have a path that reaches the player. Because we always travel to the points with the lowest values to get here, we can be sure this is the fastest path to get to the player, and then finally, our henchmen will chase us along this path. Now that we have A* implemented, the henchmen and enemies can chase Mr. Cloak around corners and avoid getting stuck on objects. I also added in a chase area for each of the henchmen, which is just a simple polygon collider I can shape into an area that the henchman is tied to. That way, once a henchman starts chasing you, you have a chance to escape them, and they won't infinitely chase you around the entire map. Flashlight guys also utilize A* to reach their destinations correctly, and I added the ability for flashlight guys to traverse between their waypoints in two ways, either out and back or in a loop. One small bug that I created a temporary solution for was that the flashlight guy will sometimes quote-unquote flicker when reaching a point before going to his next destination, and you will never guess what solution I came up with. I created a little delay timer of 0.2 seconds, which makes the flashlight guy not switch animations until after this. So even though the flashlight guy wants to flicker, now he can't. I am fully aware this is a terrible solution to this problem, and I will definitely fix it at some point. Probably. Maybe. Other than this, the flashlight guy's flashlight is still a static 2D image, so it can beam straight through walls, which I found out can't actually happen, so this is the perfect transition into how I needed to get dynamic lighting working. After a little bit of research, the best solution was definitely to use Unity's 2D lighting system, which gives a lot of options for creating great dynamic lights. This was honestly surprisingly easy to implement, and after playing around with all the settings to learn what they did, I was able to re-implement how the lights looked with dynamic lighting fully implemented. The only problem was hitboxes for the lights. Let's say my character is behind this pillar to hide from the light. This is a static circular hitbox, and it doesn't care what's in the way. Just as long as you're within the perimeter, it'll alert the guards of your location. We can solve this with something called ray casting. Essentially, what we can do is cast a ray, or multiple rays, from the center of the light object, and give it a max range so it doesn't leave the perimeter or angle of the light. If that ray hits the player, it'll count down a small timer and will alert the guards of the player's location when it hits 0. I had two ways to do this. Either cast rays that don't move from a set number of directions from the light, or essentially only have a few rays cast from the center and have them always be cast towards the direction of the player. I chose the second option, as I figured casting a fewer amount of rays per light source would be a good optimization to make. Now, if we have an object in between the light and the player, it'll block the ray from hitting the player, just like we hoped. With these two big features added, I felt good to start making some levels. But halfway through creating my first level, I came to the tough realization that this game just doesn't have enough content in it. For a game about avoiding the light, I needed some more different kinds of light, and also some cover so Mr. Cloak has a variety of objects to hide behind and to liven up the game world. So, it looks like we need some cool new pieces of cover. So hold on just a second. Alright, that was easy. Just kidding. It went something more like this. Does this need more texturing? Yeah, definitely. Ugh. Nope. After a few hours of work, we have some new assets. So now, introducing
Box, Barrel, Chest, Grave 1, Grave 2, Grave 3, Bookshelf, Fallen Pillar, Obama, Mrs. Pop, Corcoran's Mom, the 1989 Denver Broncos.
Still being a beginner pixel artist, some of these assets took me a while to make, with my biggest enemy being the barrel. I don't know what it was about this barrel, but I think something about the roundness of it made it harder to perfect than other assets. So, after creating an army of barrels because I couldn't decide which one fit best, I decided to ask Marcin which one he liked best. So now we have some cool different pieces of cover for Mr. Cloak to hide behind. But what about some new light sources? I ended up creating 3 new light sources that I think each one will improve levels a ton. Starting out with a lighthouse. The idea of the lighthouse was that it would scan the area in a predictable path, either in a full circle or rotating between 2 set angles. and the player will have to dash from one piece of cover to the next without getting caught in the light, which would alert the guards. The design of this was kind of weird, as I had to think about, what would an underground lighthouse look like? But after a few iterations, I think I got it. I then had to attach a dynamic light to the lighthouse and make it be able to fully rotate in a circle, or just between two angles. The rotating around in a circle part was easy to program, as rotation can just be applied to the light at a steady rate. However, rotating between 2 points became an issue. If the light rotates between 2 points and doesn't accelerate and decelerate before stopping, it feels weird/lazy. And applying a smooth acceleration to the light, speeding up and slowing down between the two start angles looks and feels a lot better. The problem is, how should the light know when to start decelerating, such that it comes to a complete stop by the other angle? The answer is calculus.
Welcome to lesson 2. I'm just kidding. We both done enough learning today. Let's just skip over the calculus.
Cool. Now we have this awesome light that we can dodge and make a bunch of fun puzzles/technical sections in levels with. Next, we have a light threat that I think is even cooler, called the light turret. This weapon fires a light orb at set intervals, which can bounce off walls a number of times before breaking. Kinda like how a Koopa shell works when it's thrown in Mario Kart. This will make the player think twice about if they're safe behind a piece of cover, because light orbs are able to bounce around corners and walls, adding another element to make level design even more fun. Once again, the art felt weird to make because I had no idea what a fantasy labyrinth turret would look like, but I think I did a pretty good job in the end. Now, we just need to program in the Pong-esque way the ball will bounce off the walls by getting the angle the ball is hitting a wall, and using that to calculate the new direction once it bounces off the wall. The last light I created is simple, but will add a lot of fun mechanics to level design. The on-off torch. Players will have to time running past torches before they flicker back to life again. This will be fun for precision timing in sections of the level where I don't want players to linger. The code for this was pretty easy to implement as expected with just a simple timer, but I really liked how this animation turned out for the light flickering back on. Lastly, I really liked the flashlight guy, but wanted something a bit more threatening where the light would be harder to avoid. So I decided to make Flashlight Guy's brother, Lantern Guy, whose light just goes in a full circle, essentially like a moving campfire. Now, instead of just dodging an initial light, Mr. Cloak will need to keep actively avoiding that light as he passes by.
With these new lights and enemies in the game, I've increased the creativity and variety I'm able to put into each level tenfold. And I know that not only will players have a ton more fun playing all the awesome levels I'll create, but I'm also going to have a ton more fun making all of them. Also, the Mr. Cloak Steam store page is now live, so please check that out in the link in the description, and give the game a wish list there if you're able to, because that helps the game a ton. It kind of essentially boosts the Steam algorithm to show Mr. Cloak to more people. So please do that if you're able. Also, because we're now making a ton of levels for Mr. Cloak, we're looking for playtesters that want to play these levels and give their feedback to make the overall final product of Mr. Cloak much more fun. So if that interests you at all, please join the Mr. Cloak Discord, linked in the description, to play all these levels for free, and also receive a bunch of updates about the progress that we're making on the game. It would mean the world to me if you give the video a like, if you like the content, and subscribe to keep following along with Mr. Cloak's development journey. Alright, I need to get back to work, but I will see you all in the next episode. Thanks for watching.